Electrical machine design. Good morning to all. Topic: apparent and real flux densities in the teeth. The air gap flux while entering the tooth section divides along two parallel parts, one part passing through the tooth and the other through the slot. The flux carried by the slot is appreciable if the working flux density in the teeth is greater than 1.8 Tesla. Apparent and real flux density in the teeth. Topic: as a result, the actual flux carried by the tooth section is less than the air gap flux, usual flux. If the actual flux carried by the tooth and cross-sectional AI and B real is equal to pi I divided by AI. Pi I is flux, actual flux. The flux density calculated on the base of total air gap flux and cross-sectional area of teeth AA is known as apparent flux. Density B apparent is equal to pi s divided by AA. That is second equation, where pi s is equal to total value of flux over one slot, which out of which pi I passes through the tooth section and pi n passes through the slot portion. Pi s is equal to pi I plus pi n, that is third equation. Pi s divided by capital AI is equal to pi I divided by AI plus pi n divided by AI. B apparent is equal to pi I divided by AI plus pi n divided by AI. B apparent is equal to B real plus pi n divided by A n into A n divided by AI. B apparent is equal to B real plus B n bracket of Ks minus 1 close bracket. B apparent is equal to P real plus mu naught 1 plus bracket Ks minus 1 bracket, where Ks minus 1 is equal to An divided by Ai. Ks is equal to An plus Ai divided by Ai. An plus Ai is area of slot pitch and gross length. An plus Aa is equal to towers dash into capital L. Aa is equal to Bt dash into Li. Ks is equal to towers dash into L divided by Bt dash into Li. Electrical machine design. Procedure for calculating the ampere turns for the air gap using Cortez coefficient. First, air gap flux pi. Second, effective gap area Ag dash is equal to Kf tau p L. Kf is field form factor, tau p is pole pitch, L is length. Third, gap flux density capital Bg is equal to pi divided by Ag dash. Procedure for calculating the ampere turns for the air gap using Cortez coefficient. Fourth step, gap coefficient for slot Kgs is equal to tau s divided by tau s minus Bs into 1 minus del s. Del s is Cortez coefficient for slot, tau s is slot pitch, Bs is width of slot. Continuation of fourth step, 1 minus del s is depends upon the ratio of slot width to air gap length. Fifth step, gap coefficient for ventilating duct Kgb is equal to capital L divided by L minus Nv Bv bracket of 1 minus del V close bracket. Procedure for calculating the ampere turns for the air gap using Cortez coefficient. Fifth step, 1 minus del V is Cortez coefficient or ducts, which depends upon the ratio of width of the ventilating duct to air gap length. Sixth step, total air gap coefficient Kg is Kgs into Kgb. Seventh step, total ampere turns for the air gap ATG is equal to 0.796 Bg Kg Lg into 10 per 6. Eighth step, assume 3 ventilating ducts each of 1 centimeter width. Good morning to all. Electrical machine design. Subject. Topic: ampere turns for the air gap. Problem. Questions: calculate the ampere turns required for the air gap of a 4-pole DC machine given flux per pole is equal to 0.028 Weber, pole pitch is equal to 0.26 meter, pole arc is equal to 0.18 meter, length of the armature is equal to 0.22 meter, air gap length 0.35 centimeter, number of slots is equal to 28, size of the slot 1.2 centimeter into 4 centimeter, pole width is equal to 0.1 meter, pole height is equal to 0.12 meter, diameter of armature is 0.33 meter, kgs is equal to 1.1 that is given value. Pi is 0.028 Weber, that is given values. Continuation of solution. Kf is equal to pole arc divided by pole pitch is equal to 0.19 divided by 0.26 is equal to 0.69. Ag dash is equal to Kf tau p into L 0.69 into 0.26 into 0.0396 meters square. Bg is pi divided by Ag dash 0.028 divided by 0.0396 is equal to 0.7 Tesla. That formula I explained in theoretical classes. KGS, that factor is equal to tau s divided by tau s minus Vs open bracket 1 minus del s close bracket. Tau s is equal to pi divided by s is equal to 0.039 meter. Pi into 0.33 divided by 28. KGS value is 1.1 given. Put in KGS is equal to tau s divided by tau s minus Bs into bracket 1 minus del s bracket. Put in equations. 1.1 is equal to 0.037 divided by 0.037 minus 0.012 into 1 minus del s close bracket. 1 minus del s value we obtained 0.28. 1 minus del s is equal to Bs divided by Lg. 1.2 divided by 0.35 is equal to 3.42. 3.42 is belong to 0.28. 1 minus del V is equal to Bv divided by Lg is equal to 1 divided by 0.35 is equal to 2.85. For 3.42 value, 1 minus del s value is 0.28. For 2.85 value, we find out 1 minus del V value. 0.28 divided by 3.42 into 2.85 is equal to 0.23. That is 1 minus del V value. We obtain new value. KGV, that is factor value, is equal to L capital L divided by L capital L minus NV BV bracket 1 minus del V close bracket. Put required values in KGV formula. 0.22 divided by 0.22 minus 3 into 0.01 into 0.23 bracket. That is KGV value we obtain 1.03. Continuation of solution. Therefore, Kg is equal to Kgs into Kgv. Put required values. 1.1 into 1.03. We obtain Kg. Factor value is 1.133. ATG is equal to 0.796 Pg Kg Lg into 10 power 6. Put required values. ATG is equal to 0.796 into 0.7 into 1.133 into 0.0035 into 10 power 6. ATG value is 2209.5. That is, ATG value is approximately equal to 2200. That is, we get answer.